More on Cyclone Idai now. It has been downgraded. The United Nations says over 100 people have already died after weeks of heavy rain and flooding in Mozambique and Malawi. A team from Red Cross Africa is trying to reach the city of Beira by road as flights have been cancelled. ENCA meteorologist Annika de Beer has more on the region's weather.
Intense tropical cyclone Idai made landfall on Thursday evening along the coastline of Mozambique near Beira. Wind speeds of 170 kilometers per hour as well as heavy rainfall and extensive flooding has since been reported. These images were taken in Beira yesterday and it shows extensive damage to some of the buildings as well as trees being uprooted in the very strong winds. This system is now referred to as Idai as it is not tropical cyclone strength anymore. However, it still continues to cause a lot of rainfall in Mozambique and now also in parts of Zimbabwe as the low pressure system continues to move westwards. Let's take a look at the wind forecast for the rest of the afternoon. As we can see, the winds are not a concern anymore. They will start moderating along the coastline of Mozambique and also some fresh winds expected in Zimbabwe. But as far as rainfall is concerned, there is still a high possibility of more flooding and heavy rainfall in both Mozambique and Zimbabwe. The red color indicates up to 100 millimeters of rain in the next 48 hours, with the white color indicating up to 300 millimeters of rain in the next 48 hours in central Mozambique as well as the southeastern part of Zimbabwe. And already we have received reports of flooding as well as heavy rainfall in Zimbabwe. This video was taken in the southeastern part of the country. So we will remain on high alert for heavy rain and flooding in both Zimbabwe and Mozambique for the rest of this weekend.
Malawi, Mozambique and Zimbabwe have felt the brunt of now ex-tropical cyclone Idai. Close to 1 million people have been displaced while many others have died. What's behind the weather patterns on the continent? We're joined now by climate change expert Professor Bob Scholes, and thank you very much for your time. You're from the University of Witwatersrand.
That's correct.
And I understand that you do research into systems ecology and climate change. Is there a link between cyclones and climate change?
Well, certainly there is. Cyclones are fed by warm water. So they are just, if you like, little whirlpools in the atmosphere of the Earth. But if they travel over a large patch of warm water, it spins them up and gives them their power. And that's why they become a cyclone. And then when you cut them off from that, for instance, when they drift over land, they cut off from their power source, which is why they become downgraded. All that means is they stop spinning so fast, and so you don't get the high winds, but they're still full of all that water, and that gets squeezed out of them like a sponge. And that's what's happening in eastern Zimbabwe at the moment. So with the warming of the world, we're getting bigger accumulations of warm water in the western side of the Indian Ocean. And so we would anticipate that the power and frequency of these kind of storms will increase in future.
So what does that mean for the southern African region? I mean, the term cyclone is not one you often hear in relation to the likes of Zimbabwe, which is on the eastern side of the continent. So what does this really mean for the southern African region?
So technically it's called a cyclone when it's still over the ocean and spinning and has those very high energy winds in them. And that's what causes most of the damage in that circumstance, along with something called storm surge, which is, you can imagine a storm whipping up waves. And this one evidently whipped up waves of nearly 10 meters tall. But what is more difficult to imagine is actually pulls up a whole bulge of water of about 2 meters high, and that's what causes all the onshore flooding. And then when it moves over the land area, it is no longer as full of energy, and that's when we call it simply a tropical depression. And we have had those things come over South Africa in the past. What was Cyclone Des Moines, I think that was 93 or something like that, was the last big one, dropped 300 millimeters like this one is within 24 hours. That's nearly a half a year's of rainfall, in one day, and that just, washes out bridges and whatnot.
And people too, as we saw in Mozambique.
Absolutely. And so the real question is, these cyclones all move from the east to the west. That's the way they're generated in this sort of subtropical zone. And up till now, Madagascar has protected Africa from those impacts. So Madagascar gets hit by these things several times every year. But if the warming of the world causes those storm tracks to move just a little bit further south, some of those cyclones will miss the southern tip of Madagascar and hit into northern Natal. And then we will have not only these high rainfall events, but also the extreme wind events that are associated with them.
And you've spoken about the relationship between climate change and these cyclones. Is there anything that can be done to try and prevent it? What measures can be taken to try and push back against these problems?
So all we can do really is reduce the amount that we allow the climate to warm, and that is what the Paris Accord is all about. Even if we were able to meet the Paris Accord targets of not letting the world as a whole warm more than 2 degrees Celsius, we will still see large changes in the climate, because that's still about twice what we've seen already. The problem is that we're currently on track for actually about 3.6 degrees warming, not 2 degrees warming, because people have said, yes, we're going to do this, and this is what my contribution is going to be. And when you add up those contributions, we're heading for 3.6, and that would cause major problems in southern Africa.
So you're talking then at a government level, the kind of commitments that states are making to actually address the issue of climate change.
Right. So on the adaptation side, if we can't stop these things from happening, and we actually have to stop them from happening too much, but even now we're kind of committed to a certain degree of this. The other side of it is what we call adaptation. In other words, this is going to happen. How are you going to prepare yourself for it? And a lot of that is, for instance, around things like these tropical depressions. You have to change your building codes and your bridge specifications. What used to be a storm event that would come around maybe in 100 years, which is what the bridge specifications are set at, is now coming around every 15 years. And so you have to build bridges higher. You have to, change the way you construct roads and stormwater drains and all that sort of thing.
So that then has a knock-on effect in terms of the structural kind of requirements.
It becomes very expensive.
Yes.
Yeah.
And I suppose in areas where there's a little development and where structures are perhaps quite informal, that then has a severe impact on the human population.
Yes, it does. Many of the deaths that we see in association with events like this are from structural collapses, so mud-walled houses collapsing on their people, landslips, or people trying to cross rivers on flimsy structures which are submerged and get washed away.
I'm interested just in one of the dams in Mozambique, Cahora Bassa, which we know is linked to the power supply to South Africa. How does that fit in terms of Idai and now what we're seeing with the Eskom cuts? I mean, I know that's not your field of expertise, but what can you tell us on that?
So I was really surprised to hear that Eskom are blaming the current load shedding on loss of hydroelectric power from Mozambique. The dam itself will be unaffected. It's a huge dam. It's on the Zambezi, and it draws its water from western Zambia, not from the area that's been falling on. So if this is the case, it must be the transmission lines. Those are some of the longest transmission lines in the world. They're over 1,000 kilometers long. But I would not have expected them to be taken out by a storm like this. And the reason is that, as I said, once the storm moves over land, it loses a lot of its oomph. So it's no longer blowing at, close to 200 kilometers an hour, which could take down a power line. It's now blowing only at about 50 kilometers an hour, and a power line should be fine under those circumstances. But really, at this stage, we don't know what's going on.
It's a great mystery.
Yeah, and we shouldn't be getting more than quite a small fraction of our power from Cahora Bassa anyway, so that must mean that there's other underlying issues, and this was the last straw.
At play. Professor Bob Scholes, thank you very much for your time and your input on Idai.